x minus 2 bracket squared equals 6y. Let's compare that with our archetypal parabola then. Y squared equals 4a capital X. So here the y-axis, capital Y-axis, corresponds to the value x minus 2. So we're shifting the y and x-axis around. And the x-axis corresponds to the little y-axis. And the value of a here, well, 4a equals 6. So that tells us that a equals 6 over 4, which is 3 over 2. So that's what we've got then. These are the correspondences. So we're shifting, our x becomes y and our y becomes x. So instead of it going, the parabola going this way round, it's going to swap the y and x axes. So in our mind's eye we see it that shape in principle. But also the x value is shifted over here, isn't it? So the y that's the x is shifted over 2 units. So when x equals 2, see it here? If I mark off the 2 point then, because when y is 0, x minus 2 is 0 and x equals 2. So when x equals 2, put that in there, you'll see that y is 0, as we said. So here, okay, that's what we're going to have then. That's shape. Here's our vertex. So let's mark that point. That's the vertex. So we can go up vertically from that. This is the axis of the parabola from the vertex. And this is the axis. Now, A0, well, instead of it being A0, the x and y axes are swapped around, so it's not A, so to speak. But it's at 2a, and a is at 3 over 2, so you've got 2 and 3 over 2, isn't it? There's our focus, so let's mark that off. Okay, so now we've got the focus is at 2, 3 over 2, the vertex is at 2, 0, so the directrix must be back here at minus 3 over 2 horizontally. This value here is minus 3 over 2, and that's the directrix there. So let's mark that one off. And now we can sketch the actual curve itself. So let's have a go at that. So we come out from the vertex and we try and draw a quadratic shaped curve. Symmetrical both sides, of course, around the value x. This equals 2. Okay, good. So let's just check now. So let's do a quick check that we've got everything correctly identified. So let's draw a point P here. And we'll look at the distances squared. Must equal one another, mustn't they? So this distance must equal this distance here. Drop down to the directrix, perpendicular. So check. So this distance is x minus 2 squared plus y minus the 3 over 2 squared must equal this distance here, which is y plus 3 over 2, isn't it? When you drop the vertical there, squared. The distance is squared, of course. So this can stay as is. Here you're going to get a y squared, which will cancel with the y squared here. You'll also get plus 9 over 4, which will cancel with this 9 over 4. Then you're going to get a minus 3, aren't you, when you have two lots of this? Minus 3y. And this is a plus 3y. So move the minus 3y over here. And we get 3y plus 3y is 6y, which is what we wanted. There we go. So the sketch looks as though it's okay.